So this video isn't going to be about modern hardware. It's about a piece of software I made as like an instruction manual as to its usage, because watching a video is probably easier than reading a text manual. So turning back over a year, I was building a project for university, an 8-bit integer ALU, and I needed a way to power the device, so I began searching for a fairly decent linear PSU, and I found this one, the Korad Ka3005 SP programmable PSU. The interesting thing here is that it's programmable. The thing has a USB and serial connection on the back. However, as far as I'm aware, Korad never made any software to control the device, meaning the only way to control a device is through the front panel, which is pretty standard, but still, I got this partly because it was programmable. So anyway, about 2 to 3 months ago, I was bored and decided to have a go at making a piece of software to control a device. A few days later, I had this. Oh, and by the way, I'll leave a link to the GitHub repo where you can get the software. It's all open source and stuff, but I'll talk about that later. So let's turn to the program. It may seem complicated at first, but we'll get through it. So the UI is split into 2 sections. The top section is the global interface. Basically, whatever you want to know about the PSU at all times, such as what voltage and current the PSU is supplying, and also whether it's turned on or not. The bottom section is split up into dedicated tabs, each with their own specific use. The first tab is the connection settings, and it's here that you can create and configure a connection to the PSU. You can also turn the beeper on and off because I had nowhere else to stick the button. Now, there is more to this tab than meets the eye. So here, as I said, you can configure the connection settings using all of the settings that .NET allows me to tweak. I won't go over the settings as the defaults work just fine. They're just there in case someone needs to have a special case. The only connection setting that's worth talking about here is the device name, as this software allows for multiple devices to be hooked up to the computer at the same time and controlled independently from each other. This means we need to be able to differentiate between one device and the other. Because of this, we can't just connect to the device. We create a logical device called a device pair, and we give it a name. We'll use that name to select and control the device later. Once we have created the device pair by pressing Create Device button, you should see the device name appear in the top section of the UI in a drop-down box. This box is how we select between multiple devices. With that logical device selected, we may now make the physical connection to it. We do this by pressing the Connect button. Now the serial link is actually active, and you ought to see the device ID show above the device's name. This data was read from the PSU itself. Also, the PSU is initialized to having its outputs turned off and its voltage and current set to 0. The next tab is for voltage and current control. You can set individually voltage, current, or you can set them both together. This one's pretty simple. The next tab is for overcurrent and overvoltage protection. Really simple. If you have the OCP on and you try to exceed your set current limit, the PSU will turn off its output. The same is true with the OVP, but with voltage and not current. The next tab is using the memory store and recall functionality that this PSU has. If you type in a voltage and current, you can save this config in one of 5 saves. You can then load this config later by pressing the corresponding load button. Pretty simple. Moving on. This is where you get the real interesting things. So the next tab is the component test tab. This section allows us to program in a series of voltages and currents that we want the PSU to output in sequence. Not only that, but this allows us to make linear voltage ramps from a beginning voltage to an end voltage. We can then set how long each one of these sequences to last for, or how long we want the voltage ramp to ramp over. By the way, the ramp works via linear interpolation with 6 samples per second. And at last, but certainly not least, we can actually save and load the test sequences. The test sequences are stored in an XML file. The next tab is maybe even more interesting, because when you run a test sequence, This software actually begins to log the power data off of the PSU and construct a table with the logged results. You will note that the logging actually starts before the test begins. This is so that you can see the beginning of the test occur. Otherwise, you couldn't know whether your log is actually starting during the beginning of the test or when the test has already been running. Also, the results of the test can be written out into an XML file using the save log function. I don't know if there is software like Excel to read in data in an XML format, but just making a record of the logs was my intentions here. The next interesting feature here is that of the console that I built for communicating with the device. The reason I made this is because I was using PuTTY to test the commands. However, you have to send the entire message in one stream, not character by character, so I made this. The console sends plain old ASCII encoded text commands, so if it is of any use to you, you can use it over any serial interface as long as your connected device takes an ASCII encoded command. The top box is where you type in the message, and the bottom box is where the reply is written to. The console isn't 100% perfect, but it mostly gets the job done. The last tab is about the licensing, GPL v2, and the system requirements, although these system requirements are a little misleading, as it implies this software only runs on Windows. It actually will run just fine on Linux and Mac OS using Mono, as this is written in C#. The only and huge problem with this on Linux is that Linux's I/O ports are represented as a plain file that you have to write to and read from, and this software won't do that. I have tested it on Linux, and the software runs fine. You just can't connect to anything, basically rendering the software useless. Now coming back to the licensing, this is GPL v2, free and open source, and for the most part, you can do whatever the hell you want with it, although there is a README which basically tells you what you can and can't do with it. Anyway, that's this software. The reason I made this video is that, as far as I'm aware, there is nothing else out there for this PSU, and this video is meant to be an instruction manual for the software. Also note that this software only officially supports this PSU. If you have a PSU that takes the same commands, this one will work, but the other ones are unlikely to work.